Hi everyone, this is Matt Ingram with a set of videos on estimating the significance of LISAvalues. More specifically, I provide a set of different methods for estimating the significance and by extension, therefore, of visualizing LISAvalues in the form of cluster maps or LISA cluster maps or what some folks call Moran scatterplots, Moran scatterplot maps. The two basic categories of approaches are the permutation approach and the numerical approach, and we'll carry out both approaches and compare them. So the example that we'll be working with is the example published in Criminology in 2001 by Rob Baller and his colleagues, including Glenn Dean, Steve Messner, Luke Anselin. Um, and we're going to carry out the estimation of um, the significance of LISAvalues and generate LISA cluster maps in GeoDa, in Python, and in R. The permutation approach is the one that is implemented in GeoDa and Python. R, by contrast, implements the numerical approach, although you could program permutation analysis in R. But this is the way we'll do it, using GeoDa and Python to demonstrate the permutation approach and using R to demonstrate the numerical approach. In these videos I won't go into an extensive discussion of the technical details behind the two approaches, but I would refer you to this additional reading by Dan McMillan and then by Bivand and his co-authors regarding the numerical approach, and then for the permutation approach I would refer you to Luke Anselin's work since the early 90s. So let's take a look first here in this initial video on what this looks like in GeoDa. So if we go to GeoDa, here we are in GeoDa. You can see an R workspace in the background, but we're working with this GeoDa toolbar. And we've loaded in the data set from Baller et al. It's county level data set on homicide data. And the spatial weights file that they use in their analysis is the 10 nearest neighbors. So let's go ahead and generate that, just so we can use this, or at least load it in rather. There it is. And set that as a default, and then quickly execute our LISA, or generate our LISAvalues. We're going to space and go down to the fourth option, univariate local morans, and then load our homicide rates. Let's use homicide rates for 1990. And then generate just the cluster map. You could generate the other options, the significance map and the Moran scatterplot if you wanted, but right now let's just generate the cluster map. So this is the cluster map. This is sort of our, we want to refer to this maybe as our reference point, because we're going to be comparing the output from the other environments to this output in GeoDa. We've done 99 permutations here. Let's just increase it to, I've just right-clicked on the map here to randomization. Let's just increase it to 1,000 permutations. And this is our basic map. You see large chunks of the northern part of the United States, northern counties of the United States, are low clusters, of low homicide rates. And then we've got a large set of the southern region of the United States that are high clusters. This is our first example of a permutation approach to estimating the significance of LISAvalues. Again, the reason why significance is relevant here is that we're only plotting the significant values, the significant LISAvalues. There are other LISAvalues in these blank counties that you can see here colored in light gray. We could right-click here on not significant and make these white just to make the contrast starker. There are LISAvalues here. But the GeoDa package uses a permutation analysis to estimate the significance of these values, or rather compare the observed empirical value to an expected value, and use that comparison to estimate significance. So we're only showing the statistically significant LISAvalues here, and that's what generates this informative cluster map. So let's see what this looks like in other environments. We're going to stop this video now and then move to the next video in Python showing the permutation analysis in a different environment, and then move to another video showing the estimation in R of the numerical approach. So we'll move to those videos next.